when it snows over Antarctica, the snow tends to reflect the chemistry of the atmosphere at the time that it's snowing. So by looking at the chemical composition of the snow, we can see how the chemistry of the atmosphere was at that time when it snowed.
We can go back hundreds and thousands of years into Earth's climate to understand how not just Antarctica but also the Southern Ocean has operated, and understand how it operates naturally and how different it might be today from its natural situation. These are our two ice core drills. One recovers about a 3-inch diameter ice core, the other about a 2-inch diameter ice core, and they can go down about 100 to 200 meters, allowing us to go back 200 to about 1,000 years.
So every year you have snowfall, and it's preserved by the following year and the following year and the following year. So as you drill deeper and deeper and deeper, you go back further and further and further in time. So by looking at the cores, we can actually see how the chemistry of the atmosphere has changed through time.
We've been testing out these drills right now, getting ready to bring them on the traverse.
We will stop and set up camp, and we will set up a drill site upwind of our campsite so that we don't contaminate the area where we're going to drill. So what you'll see happening here is the drill coming out of the hole on this steel cable. The way this drill works is similar to the way you would drill a hole in the wall of your house. But the only difference is our drill bit is hollow, and so while we're drilling, the core is actually captured inside the drill bit.
We have the windbreak up here because sometimes we'll get winds of 10 to 20 knots and makes it hard for the people to work. They very often have very little on their hands.
He's about to tip the whole drill barrel up so that he can extract the core. So the way the drill works, it goes down the hole, drills for 1 meter. Pull will push the core from this end and the chips will empty. So there are the chips. And here comes the core. And there we have a perfect meter of core.
Once the core comes out, we basically examine it, put it in a box, ends up on these sleds, and we take it back to the various institutions for analyses.
If you have a very strong wind blowing over the ocean, it will tend to whip up a lot of sea salt spray and then deposit that on the ice sheet. Whereas if the winds are very weak, you won't get so much sea salt. So when we look at the core and we see how these levels of sea salt, which is sodium and chloride in this case, if we look how the level of sea salt has changed through time, we can actually see how wind strength has changed.
What we've learned in the past is that once Antarctica does begin to change, once the fresh water comes out, raises sea level, changes ocean circulation, changes the extent of sea ice, and wind systems begin to change around this area, it has the potential for triggering some very, very large changes, not just in the southern hemisphere, but throughout the entire globe.
We probably understand it better now than at any time in the past. And we're in a position where we can start saying with much better certainty than ever before how it might be likely to change in the future.